Hi guys, here's a video about how to graph by the zeros. This is the topic we're going to be working on this week. I thought I'd just take a tough one here. First thing, notice it's a polynomial and it's in factored form. And by that I mean I have all these terms multiplied together. It's called graphing by the zeros because we're going to set each of these terms equal to 0 and find the zeros. And this is easy enough. In fact, I'll list it right below here. First of all, this x tells me that 0 is a 0 because if I let x be 0, the whole function will zero out. Right next to it, x minus 2 tells me 2 is a 0. Now that x minus 2 is to the third power, so what we do is we call that multiplicity 3. We'll talk about what that does on the graph. If x plus 1 equals 0, then negative 1 is a 0, and that has multiplicity 2. And finally, negative 4 would also zero it out. That has multiplicity 1. So what does this mean? Well, I found 4 zeros, in other words, 4 x-intercepts, and these are really the only 4 points I'm going to plot. I'm going to plot 0, I'm going to plot 2, I'm going to plot negative 1, here's negative 1, and I'm going to plot negative 4 over here. And of course, this is a rough sketch. It's not to scale. You can see I don't have a grid. In fact, I don't even have all those little hash marks on my axes. And that's okay. The next thing we do is we look at the degree, and we get the degree by just adding up the exponents, which is the same as adding up the multiplicities. You can see here I have 1, 3, 2, and 1, and if I add that up, I actually get 7. So this is 7th degree. That's a very high degree polynomial. It's 7th degree. The only thing that really matters is that it's odd degree. And odd degree means that you normally would start low, and you could wiggle around a little bit and then finish up high. Now this is a negative 7th degree, so if you are negative, I guess I can kind of color code this. If there's a negative in front, everything gets reflected and you start high and finish low. So actually our graph is going to look a lot like that red graph there. It's going to start in the upper left and end in the lower right. And really, guys, that's all the information you need to do to graph one of these polynomials, provided they're in factored form. So I'm starting in the upper left, up here, and I'm going to cross through negative 4. Now, negative 4 has multiplicity of 1, which means I cut straight down through it. Okay, almost looks like a straight line, like a linear function, because it's to the first power. And then eventually I have to turn around and I have to hit negative 1. So at some point I'm going to have a relative minimum. I don't know where it is, probably right in the middle of negative 1 and negative 4. And I'll turn back up towards negative 1 because that's the next 0 I have to get. Now there it's multiplicity 2. Multiplicity 2 means I'm going to be just tangent to the x-axis. Almost looks like a parabola there locally, right? So if I come up, I just have to graze it and be tangent and bounce back down. So that's, I can color code just that part in green. That's really small there. And then I have to quickly turn around because the graph is also going to hit 0. So right here, it comes down, but it quickly turns around and comes back up. So I have another relative minimum, and I'm going to hit 0. It's multiplicity 1 there, so it goes straight through, right? It doesn't do any wiggling. It's, it's not the greatest picture of mine, but it goes straight through. And then I have to quickly turn around again to get to 2, so I have to have a maximum. Now here it's multiplicity 3, which looks like a horizontal inflection point, which is that shape right there. So multiplicity 3, let's color code that in orange. Multiplicity 3 has this shape, almost like a cubic function. And finally, the parts that are multiplicity 1, maybe I don't know, multiplicity 1, I'll do that in gray. They look linear, like it cuts straight through. Okay, and that's the general shape of the graph. Okay, I'll highlight a couple more things that we talk about in this chapter. We talk about things called extrema. Extrema are just maxes and mins. Okay, so where are the extrema on the graph? Here's a minimum right here, right? There's also a little minimum right there, really hard to notice, okay? There's a maximum here at the x-axis at -1. That's a max point. There's also a maximum here. Again, we're not sure of that location, and that's something you find in calculus class. So here we had 4 what are called relative extrema. It's worth noting that a 7th degree can have as many as 6 extrema. This one just happens to have 4, but you can have as many as 6. So that's the deal. You know, first of all, this only works if you have it factored. So if you have a polynomial that's unfactored, you have to factor it first. Then you list all the zeros with their multiplicities, and their multiplicities kind of describe how the graph crosses the x-axis at each location. And finally, you have to look at that end behavior, right? Odd degrees go in opposite directions. For what it's worth, even degrees would go in the same direction. So even though it's not in this problem, an even degree would start high and end high, and a negative even degree would start low and end low. But, you know, that's for another day. Okay, guys, I hope